All right, so tomorrow on the test itself, this will look like the back page. It will look a lot like this, okay? It's going to be a page that every one of you has a copy of that you can write on. So tomorrow, the first half of the test, or big chunk of the test, is Scantron. This last part will actually be fill in the blank, write out your answer sort of things. This first one, this lady's opened up a donut shop, and we don't really care about a whole lot once we see that word per. And I only put one of them in there that's a per. It's a dead giveaway when you see that word per, okay? Because whatever comes before the per is our dependent, and whatever comes after it is independent. Now you just have to realize how to word these. List the independent quantity. Well, it has to do with these donuts, but it's not the donuts themselves. She's selling them by the box. So I would put number of boxes, okay? List the dependent quantity. It is money or money made in dollars, okay? 16, similar. It says the family will spend several days swimming with dolphins on vacation. Every time they go, it will cost $250 for the entire family, and they're trying to budget for the trip appropriately, okay? So the independent quantity is the number of times they swim, or number of swims, or something like that, okay? And the dependent quantity, what that determines is the total money spent or budget, okay? Something along those lines. This one is not as simple as a per, but you can interject a per in here, okay? Every time they go, it will cost $250. That's saying it's costing $250 per trip. So how would you say that with the word per in it? You'd say it's $250 per trip. That means the number of trips or the number of swims is independent because it came after the word per, and the amount of money is the dependent because it came before the word per. 17 and 18 are extremely important questions. They're going to be worth more than the rest of the questions on the test because they require you to do two things. And these two things must match. Okay? What do I mean by that? I read down through here, I see function, continuous, exponential, decreasing. That one to me tells me the most because exponential is a function family. That means it's an elbow. Here's what you can't do, okay? You can't just say, oh, here's an exponential equation, and here we go, there we go, done. It's decreasing, it's exponential, and that's exponential. We don't know if those match. You didn't actually do anything to test if those matched or not. So what you really should do is you should start out in the calculator, okay? Here's a little graphing tutorial again. We want to go y equals and clear out whatever's there. But I have to start with an exponential now. That's the tackle that point. Exponential means it has some base that's a number and has an exponent that is a variable. So something like 2 raised to the x. Now I want to graph this, so I press graph. And I try to see, is it what I want? Function, yes. Continuous, yes. Exponential, yes. Decreasing, no, it's not. So let's play with that function. Let's try to make it decrease. Well, you can add some numbers to it, multiply some stuff to it, whatever you want, but we also learned to flip something upside down, the quickest way is usually to at least try throwing a negative out front. So we throw a negative out front and look at our graph again. There we have it. We have our decreasing exponential graph. Now, the final thing that's of note, because it's easy to just copy this down this equation, that's negative 2 raised to the x power. The final important thing to make sure you get right is the sketch. Because you can get a sketch wrong. I'm not particular about them. I'm not going to be like, ooh, it's just a little off here or there. But you can get your sketch wrong. What I mean by sketching a graph is a loose, quick illustration, but what you need to pay attention to are some of the clear things. Look how this rides along the x-axis. Then it bends down and crosses. Where it crosses is extremely important. Try to get that about as close as you can. That's really the big points that I can help check. Okay, crosses right there at -1, and then it goes down to infinity. So I'm going to try to mimic that right here. It's going along, it crosses at -1, and then it goes down. So I think I probably made mine start crossing a little too early, but look, it's pretty close, okay? Actually, it is really close, okay? Starts crossing down right here, crosses -1, then goes down to infinity. Pretty good, that's a sketch, okay? I didn't count out spaces, I counted out this space, this one's important. Crossing and this. I didn't count out all the little things in between. I didn't plot a bunch of points. It's just it's an accurate sketch. It's probably what I should call it, an accurate sketch. Number 18, same type of problem, different rules. clear out whatever we had. Function, continuous, has a minimum, does not pass through the origin. There's only two types of functions that we learned of that have minimums. One of them is absolute value, and we're not using that one. We didn't learn how to write that one at all. Okay? So the fact that it has a minimum should leave you with only one option. This has to be quadratic. And the key thing about a quadratic equation is that it has some sort of variable squared as its highest power. So let's start out with that. Don't start out by writing it up here. You don't know if it's going to work yet. Let's start out in our calculator. We have y equals x squared. Okay? Let's take a look at that graph. Oh, well, there we go. It's a quadratic. It's continuous. It's a function, and it has a minimum. Great. Here's the problem. We don't really know if that passes through the origin. It actually looks like it goes down and hits it. So that one's probably going to fail. Okay? It does not pass that last point. So we sit there and say, okay, well, how do we make it not hit the origin? Well, on the last problem, Mr. Sherrill threw a negative out front. Let's see what happens when we do that. We're just testing stuff. Oops, that didn't work either. And in fact, look what happened when we had a negative. Now we have a maximum. So we went backwards there. We don't want that negative at all. Let's go back to where we were. We got this x squared, and we want to learn how to move it. So maybe you think, okay, let's try throwing a number out front. 2x squared. Okay? Oops, I accidentally double squared that. We don't need that one outside. Sorry about that. Oh, I'm bungling up this whole thing. When in doubt, clear it out. So we take this, and we just had our x squared. Let's try throwing a number out front. No, that didn't move it either. So we're kind of running out of options. I'm going to try putting a number out at the very back. So we're back with our x squared. Let's try adding a plus 2. Oh, there we go. It did what we wanted. It moved it away from the origin. There's actually several ways to do this. This is the most basic way. Okay? You'll also notice that if you actually do the extended equation, x squared plus x plus any number 2, that it'll also do that. So that moves it away as well, okay? Having that extra x in there. But let's go back to our original one, our easy one. X squared plus 2. It accomplished everything we needed. Now we have to sketch it, okay? Well, we see that it's even on both sides, right down the middle, right here, and it crosses at 2. That would be your important thing. So I would actually start this at 2 and then just draw both my wings. Okay, there's my parabola. It is x squared plus 2. Okay? That would be the last page of your exam.